Don't hang up that phone. We've found what you're looking for. Welcome to the Let's Talk Cabling Podcast with Chuck Bowser, RCDD. Well, seeing how we're pulling Category 6A, the most powerful twisted pair in the world, you got to ask yourself this one question. Did I pull 295 or 300 feet? Well, do you feel lucky? Do you, punk? What exactly does RCDD stand for? Registered Communications Distribution Designer. Just the expert you need to ensure your cable plant performs exactly as designed. The elite professional, knowledgeable, and experienced in leading-edge ICT design principles. Now, send the new guy to the truck for a bucket of dial tone and the cable stretchers, while you listen to an informative program on telecommunications.
Thursday night. Whoa, that's way too bright. Holy Toledo. What is going on with that? Thursday night, 6 p.m. Eastern Standard Time. Let's try that over again. Thursday night, 6 p.m. Eastern Standard Time. That can only mean one thing. Live after hours with your favorite RCDD. And you know that's me. You know that's me. Don't even try to pretend like it's not. We all know that I'm your favorite RCDD. Got a special show for you tonight. Special show tonight lined up. Lots to talk about. Lots to talk about. Man, I tell you what, when it rains, it pours. I've been having computer issues, as most of you already know. And it's been giving me lots of problems. Lots of problems. That's okay. I've got it to get fixed here really, really soon. So, you guys might have noticed, I haven't been around for a couple weeks. I was on vacation. Took a 2-week vacation, went to Tennessee, Georgia, North Carolina, South Carolina, went camping all over the place, went to Falls Creek Falls, gorgeous state park, a bunch of harvest hosts. And then when I came back, eye injury. Yeah, holy smokes. Yeah, I was mowing the lawn, and it launched a piece of mulch into my eye. Man, I literally was nauseous, had sensitive to light, just all kinds of problems going on. So I haven't been around for 3 weeks. So I'm back now, though. Back now. Oh, hey, what are you drinking? It is after hours show, so I am drinking water. Yep, water. That's it. No Zevia soda for me tonight. Mostly because we drank it all on vacation. So there you go. Somebody said they were in Gatlinburg the week of the 24th. Nice. We just missed each other then. Yeah, that eye injury was no joke. No joke. So let's move on. Let's go to the acronym challenge. The acronym challenge for today is going to be AXT. AXT. What does AXT stand for? I'll give you a hint. It has something to do with tonight's show. Something to do with tonight's show. Yep. AXT. Put the answer in the chat box if you think you know what it is. Let me see if we got people answering. Shotzi's in the house. Dr. Pepper as usual. Yes, there you go, Mr. Shotzi. Thank you for coming back again, my friend. Shotzi is one of my longest, most loyal audience members. He's been around almost since day one. Okay, so nobody's guessing what AXT stands for. Nobody. It stands for Alien Crosstalk. Alien Crosstalk. Alien Crosstalk is defined as how one cable interferes with another cable, usually going down the cable pathway. But there you go. So tonight's show is going to be about testing. Actually, it's going to be a 2-part series. I'm only going to get through half of it tonight. The other half will be next week's thing. So, speaking of episodes, have you caught the recent episodes? Man, I just got done putting out a bunch of great episodes. I did one with Fiber Basics. I did one on design build. I had a guest host do the show because of computer problems. And then probably my favorite show so far to date, when I had John Daniels, the CEO of Bixie, on the show. And we talked about what was going on with Bixie. Some really, really cool stuff. Really, really cool stuff. One thing I do got to get out of the way, live streams are changing. Live streams are changing. They will move to Wednesday nights. Wednesday nights. And that's going to start next week. So if you're a regular watcher of the podcast or the live streams, know that next week's not Thursday. It's going to be on Wednesday at 6 p.m. So let's talk about common testing problems, right? What do you do when your tester gives you a wire map fail? What do you do? What do you look at if you get a length fail? What do you do if you get a fail in near and crosstalk, far and crosstalk, power sum near and crosstalk, power sum far and crosstalk? What do you do if you get issues with return loss? What do you do if you get issues with attenuation to crosstalk ratio far end or insertion loss? Covering half of those tonight and the other half next week. But I want to start off first with wire map. What is a wire map test? A wire map test basically just the tester puts a signal on each of the conductors and it makes sure that that signal goes all the way through. It usually starts with pin 1 and then works its way through pin 8. Now, pin 1 is not pair 1. A lot of people get that confused. Pair 1 is the blue pair. Pin 1 is either the orange or the green pair, depending on which wiring scheme you're using. If you're using T568A, it's going to be the green pair. If you're using T568B, it's going to be the orange pair. So it puts a signal on pin 1, and the remote looks for that signal come out on pin 1. It's making sure that 1 goes to 1, 2 goes to 2, 3 goes to 3, and you get the idea. I'm not going through all 8. I'm not. And then, so what are some of the common problems that you can run into with a wire map fail? Let's start with the easy ones. Reversals. Right? A reversal is pretty simple. It'll literally just show 1 swap with 2 or 4 swapped with 5 or something like that. Generally speaking, when you get those reversals, one side wasn't terminated right. They terminate instead of doing white, blue, blue, white, they did blue, white, white, blue. All right, that's a common problem. The easiest thing is, and usually when you're testing, and you just always bring up the question, when you're testing, do you fix the problem while you're testing or do you do a cut sheet? That's always the question. Put in the chat box, what do you do? Do you do a cut sheet and then come back and fix everything at once, or do you fix as you go along? Because there's really no right or wrong answer to that, actually. Kind of really depends. So if you're doing the fix as you go along, the person at the patch panel just look at the connections, make sure nothing's reversed. And if it's not, then you know it's at the jack. So just pull off the jack, fix it, terminate, way to go. Then you have transposals. Now, transposal is a little different than a reversal. A transposal is where you flip entire pairs. Okay. The most common problem with a transposal, one side's terminated T568A, the other side's terminated T568B. That's the most common transposal issue. So entire pairs are flipped. Again, same thing. If you're behind the patch panel while you're doing fixing as you go along, take a peek at it. If it's not, then it's obviously at the jack. Then the next problem is an open. Now, open will show as a break in the line, right? So when you look at the wire map. So pay attention, see which conductors are open, right? And then start doing your troubleshooting on that. Now, here are some common problems. Probably the most common issue with an open, the conductor was not terminated correctly at either the jack or the patch panel. So take a quick look at that. And here's a rule of thumb. When you're terminating, as you're terminating, lay the pairs in, verify them, and then punch them down. And it only takes a split second. Because what happens is we get stuck in working in our normal mode, and that stuff like that gets missed. So with an open, either it wasn't punched down all the way. So what you got to do is you got to look at the side of the jacket, and you'll notice there's like a little V groove, and then that conductor, if it's not all the way down, pull it back up and re-terminate. A lot of times, if you don't have your punch tool set right, or if you don't have your punch tool set at a 90-degree angle, that will cause that. Another problem that you can run into with opens is and this is less likely, but it's happened. You've got a broken wire somewhere. The cable got pinched somewhere. It got pulled over a sharp piece of metal and it cut through the jacket. It cut a conductor. In that scenario, you can use the TDR function and wire for excellence is in the house. Use the TDR function on your tester. Look at the footage on that. Go to that footage. Look for physical damage. Please don't splice that cable. If it's broken, replace the cable. The customer paid for a brand new cable. Give them a brand new cable. Another problem that you'll find too with opens is it has to do with termination. I've seen sometimes where somebody has put two conductors on one slot, not paying attention. So they put like the tip of one pair on top of another one. Well, you're not going to get continuity that way. So again, a visual inspection should take care of that. Now let's talk about shorts. Okay, so a short, you can have a short between two conductors. You can have a short between all of the conductors. I did a project once where the sheetrock guys zipped up a wall and they weren't paying attention, and my cable was going across the stud because there was a lot of excess there, and they just kind of zipped it down and squished that cable. And I had every conductor was shorted out with each other, every conductor, and it's just not fun. It's not fun. So with shorts, again, probably, and then again, usually the most probable issue, somebody didn't terminate it right. So go back and look at the jacks again, looking for double punching. You could also have where the pins are touching in the front. I've seen before where somebody tried to insert the wrong kind of pin into like a jack, and it lifted the pin, and then the pin sat down in another groove, and that was causing it to short out. So take a look at your jack, front and back. Take a look at your patch panel, front and back, and that could be most likely be your problem. You could also have bent pins. That happens from time to time. I did a project once where somebody was toning out a few cables, and they jammed the toner so hard up into the jack that they bent the pins and they were touching. So that can also happen as well. So now let's talk about length fails. You've tested the cable and it's failing because of length. So there's two potential items, right? Let's talk about what if one of the pairs seems a lot longer or a lot shorter than the others. Again, damaged cable. So what you're going to do is you're going to put on the TDR function, shoot that short one, and then walk it out, look at the cable, and see if it's damaged. Another issue with length fail is bad connections, especially if you have like a consolidation point and you don't have a good termination. That could give you a fail for length too, because it's not getting all the signal through that connection point. The other issue with length fails is, what do you do if your length fail says your cable exceeds 295 feet? 295 feet. Probably the most common thing is the cable is too long. Simple. Keep it simple, right? And what usually causes that is choosing a bad route. You're not choosing the shortest route to get to the drop, or you're not paying attention to your slack loops. You pulled some cable, you had some slack, you just coiled it up through it in the ceiling. You're only supposed to leave 3 to 10 feet of slack at the work area outlet. And in the telecom room, it's supposed to go from the ceiling to the floor to the furthest spot plus 10 feet. So you really shouldn't have a whole bunch of slack on there. But if you have too much slack on there and your cables are already 270, 285 because you left too much slack, that absolutely could cause it to fail. So let's say that you've checked it and you don't have too much slack. Now what do? You probably don't have the correct NVP set up in the tester. NVP stands for nominal velocity of propagation. It's defined as the speed of the electron compared to the speed of light in a vacuum expressed as a percentage. What does that really mean? Because those are lots of big words. When you look at a communications cable seems to be in a range of 0.65 to 0.75 NVP. That means the signal travels down this cable at 75% of the speed of light in a vacuum. Why is it measured in a vacuum, though? Because the speed of light changes depending on what kind of medium it's going through. the speed of light going through air is different than the speed of light going through water. The speed of light going through air in downtown Birmingham, Alabama is going to be different than the speed of light going through the air in downtown Los Angeles. You don't know why. It's because Los Angeles has a lot of smog, right? So that's why we use in a vacuum in space, because the speed of light is always 186,282 miles a second in the vacuum of space, because there's nothing to slow it down. So 0.65 means that electron travels at 65% of that. So if you have 65%, that means that signal is traveling at roughly 131,000 miles a second. And the reason it pulls it up is because what happens is when you put the NVP in the tester, it sends that signal to the end of the cable. Because of a mismatch of characteristic impedance, some of the energy gets reflected back. So now the signal went all the way out, came all the way back. It's going to take that time and divide it in half. And now it knows the length, now it knows the time, and it knows the speed. In order to find the distance, it's a simple math calculation at this point. And it's so easy. I taught a class today, and I use this as an example today. If I tell you to drive a vehicle for 1 hour, and during that entire hour, you have to maintain a speed of 70 miles an hour, how far do you travel? 70 miles. Same thing with the MVP. So you know the time and you know the speed. So it just calculates them and says, oh, this cable's 150 feet long. So like I said, NVP can range between 0.65 and 0.75, depending on manufacturers, different types of materials used for dielectric and other stuff like that. So you got to know there is a generic setting that they're in the testers, and 99% of the time, Kaylin's in the house. 90% of the time, that generic setting will be fine until you start getting the cables that are close to being to the maximum length. If you want the most accurate, there's two things you can do. Contact the manufacturer. Find out what is the NVP for that model of cable that you have. You need to know the actual model number, category rating, plenum cable, all that stuff. And they will tell you what the NVP for that cable is. You can also bench test your NVP. And that means you can take a short piece of cable, and by short, I mean at least 50 feet. The longer, the better. And you can put two connectors on it. You can go to set NVP or determine NVP, depends on the tester. Plug in the testers. The tester's going to ask you, how long is this cable? You tell it how long, and you can figure that out by the footage markers on the cable. Do your math, double check your math. Tell it how long that cable is, hit the determine NVP function. It'll come back and tell you what is the NVP for that cable. And the reason you want to do that is because when you look at manufacturing, and they're putting out millions of feet of cable a year, billions of feet of cable a year. Yes, there are manufacturers putting out multiple billions of feet of cable a year. Do you think there might be a difference between a batch made on one batch compared to another? There's always going to be variances. So if you want the most accurate, do the bench test for your NVP, put in that number, and then use that to test it. So if you got the NVP set correctly and it still comes back exceeding length, you probably have an issue with your length. Go, again, double check everything. You're missing something somewhere, right? Missing something somewhere. You might also get a length fail if one conductor seems to be a lot shorter than another conductor. That's a possibility. Again, with that kind of scenario, what you're going to do is you're going to shoot the cable, the TDR function in your tester, go see where it is, go check it out. So now let's talk about near-end crosstalk, far-end crosstalk, power-sum near-end crosstalk, power-sum far-end crosstalk. Those are all just EMI, electromagnetic interference. EMI is defined as how one electronic device interferes with another electric or electronic device. So here we're talking about cables and the things in the environment that will affect the cable. With EMI, there's three components: an interfering source, a susceptible unit, and a coupling between those two. So for near-end crosstalk is literally how much one pair interferes another pair at the near end of the cable. Show my TikTok peeps. So how much one pair interferes with another pair at the near end of the cable within the first 60 feet. Far end crosstalk is how much one pair interferes with another pair, so they can see too. One pair interferes with another pair at the far end of the cable. Again, within 60 feet of the end of the cable. Power sum near end crosstalk is how much those three pair, the orange, the green, and the brown, interfere with that last remaining pair at the near end of the cable. Power sum far crosstalk is how much those three pair interfere with that last remaining pair at the far end of the cable. Okay, that's what that is. And again, they're all EMI. And then you also have alien crosstalk too, actually. Alien crosstalk is how much one cable interferes with another cable as it goes down the pathway. So what are the most common issues when you get near end crosstalk failures? Again, always go back. Don't assume it's the manufacturer. Don't assume it's somebody else. It's usually you. Usually you. So first thing you need to do is go back and look at your terminations. Did at the jack, did they untwist one of the pairs too much? Remember, you're only supposed to untwist up to 1/2 of an inch for Cat 5e and Cat 6 and 1/4 inch for Cat 6a. And the best way to avoid having to do those issues is when you're terminating it, make sure the jacket comes all the way up to the back of the connector as close as you can get it. So that way you know you're not untwisting too much. Okay. But that can also happen at the patch panel as well. And what will happen at the patch panel, and this is why some manufacturers will actually tell you the best way to terminate a cable is to route the cable into the patch panel, land the two center pairs first, which would be the orange and the green, and then do the blue and the brown. That way you get an even fan. So they'll actually, when you go to terminate them, they'll all be the same length, kind of like that. Some technicians, though, they'll route in from the side. They'll take that blue pair, it'll go right up and terminate. The white orange will be a little bit further, it'll go up and terminate. And then the green, and then the brown. Well, next thing you know, the brown is a lot longer than the blue pair is. Okay, that can cause those kinds of issues. Absolutely can cause those kinds of issues. Another issue, and this is a little bit less likely. If you've already looked at the connections and you've reached, best thing to do with near and crosstalk failures, far and crosstalk failures is re-terminate, retest. If you're still getting that issue, then take a look at the patch cords. Sometimes the patch cords can be bad. Always buy good quality patch cords. You can test that with a patch cord adapter, not a channel adapter, a patch cord adapter. Because the problem is probably not the cable, it's probably the mod end connectors. Hey, in the chat box or in the box here below, tell me, which do you prefer, pass through or traditional? Which kind of mod connector do you prefer? So you want to be able to measure that mod end connector, and that's what the patch cord adapter is going to do for you. Okay. And another issue, and this was actually a little bit more common than the last one, you might have the wrong adapters being used, right? So, there's different level tests. There's 2E testers, 3, and all that stuff. Make sure you're using the right tester. Make sure you're using the right patch cord. And you should always check the patch cord adapters. When you get your tester, because a lot of companies share testers, you always want to, when you get that tester from wherever, you want to take that tester, make sure both testers are in it, make sure that both permanent link heads, both channel heads are in it. And then you'll make sure that the instruction manual is in it and the cords to charge them up. Ask me how I know that one. Yeah. You want to make sure that that's taken care of as well. Then you really want to take a look at those heads. Look at that permanent link head. Is the tab broken off? Is there cracks in the jacket where the permanent link adapter attaches to the tester? There's some gold connections. Are they in good condition? Are they dirty? Is there stuff on? Look inside the connector. Is there dust inside of it? All that can cause you problems. Ask me how I know. Yeah, it's happened to me before. Yes. So always make sure that you check those on your testers, right? Wrong adapters. You might also even have the wrong setting set up in your tester. If the previous crew had it set up for, Cat 5e testing because that's what they were doing, and now you're out there testing a Cat 6a job and you didn't think to go into the tester to change it over to Cat 6a, that could give you a near crosstalk failure too. So double check that setting. Okay. And then finally, one thing that a lot of people don't realize that can cause crosstalk issues: a kink in the cable. A kink in the cable. Why can this cause a crosstalk problem? when you look at cable geometry, how pairs are inside of the cables, manufacturers do them in a specific process, and they lay them a specific way, and then they put the jacket on. Anytime that you do anything to this jacket, if you kink it, or if it gets crushed by a staple or something, that changes the pair geometry, and that brings those pairs closer together so they can start interfering with each other. So a kink in a cable can absolutely cause a near-end crosstalk failure or far-end crosstalk failure. Okay, always make sure that you watch out for that. All righty, so let me see here. There was one other thing. Oh, alien crosstalk testing. So alien crosstalk testing is how much one cable interferes with another cable as it's going down the cable pathway. So what happens if you have an alien crosstalk issue? Realistically, the only thing you can do is go back through the bundles and separate. There was a thought in our industry 10 years ago that with Cat 6A cable that you couldn't cable dress. You couldn't comb them nice and pretty. You had to put them in there randomly so they're all just kind of laying, randomly because they wouldn't so they interfere with each other. And that's because Cat 6A operates to 500 megahertz. So the higher the frequency, the more interference can have from it. And that was a true statement back, a decade ago. In today's environment, manufacturers have gotten really good about pair twist, pair geometry. They're putting crossweb separators inside of them. They're changing how they lay the pairs. Instead of maybe doing them at 45-degree angles, maybe you have one pair 90, the other pair 100. They're doing a lot of great things. They're getting around those issues. So alien crosstalk issue is really not going to be one that you're going to come across. David's in the house, but it can still cause an issue. And by the way, there's only one way to really test for alien crosstalk issues. You need to have an alien crosstalk tester. And that's an additional tester on top of the tester that you have now. So keep that in mind. So, and a lot of times you do alien crosstalk testing, you got to do what's called 6-round-1 testing, where what you do is you pick what's called a victim pair. And that victim pair should be one of the longest runs, and it should be in the middle of the bundle if possible, not on the ends. You can plug one tester into that. You can plug the other tester into one next to it. There comes these little port plugs. You're going to give them to your apprentice. You're going to tell them run like the wind. They're going to plug in the other side. And you're going to test the 6 cables that surround. Now, what you're really doing is you're putting noise on the 6 cables that surround the one, and you're just listening on the victim cable to see if there's enough interference that's causing it problems. So alien crosstalk issues. Again, separation is the only way to do that. But those are going to be few and far between. I couldn't even tell you when the last time I came across an alien crosstalk problem. Not since the early days. All righty. So that covers this week's. Next week, we're going to talk about return loss issues. What is return loss? How to solve that. Attenuation to crosstalk ratio far end, power sum attenuation to crosstalk ratio far end, how to solve those issues, and insertion loss, also known as attenuation to us old cable dogs. What is it, and what could be the potential problems? Okay, so please make sure you come. And remember, next week the live stream is on Wednesday at 6 p.m. All future live streams are going to be Wednesday 6 p.m. until I change my mind again. So there you go. All right. Oh, I forgot. Let me go back and check the chat box. Make sure there wasn't any questions in there that I missed. I like to go fixes that. So yeah, Shotzi says he likes to fix them as he goes along. Shotzi, Phil Klingsmith is also the same thing as well. So yeah, I think that's best is to when you're troubleshooting, make sure that you fix. Caitlin says, watch it. Beep coming in at 6:30. Here it comes. 3, 2, 1. It is 6:30. Time for the live stream to end. Make sure you join us next week for the remaining part of this. And until next time, everybody, remember, knowledge is power. And if you like this show or you know somebody who could benefit from this episode, send it to them. It's going to come out on the podcast and YouTube Shorts.